The right triangle similarity concerns on a given right triangle and drawing or constructing an altitude from the 90-degree angle towards its opposite side, which is the hypotenuse. Once that we have that altitude, we have created three different triangles which are similar to one another. Similar to this example here, we have the original triangle KAO, okay? And then we have drawn an altitude AN towards hypotenuse KO, and then we have created the three different triangles here, which are actually similar to one another. What I could advise is to break the three different triangles and place the correct labels. To do that, let me try here. Okay, how about this one, and the largest. This may not be uh, drawn to scale. Pardon for that. And we have here again 90 degrees, 90 degrees, 90 degrees. So the largest would be the original triangle. Let's have the triangle KAO with the labels Y, Z, and 4 and 9, which would actually be computed as 13. Okay, again, because of the segment addition postulate, Kn and No is the combination, a combination of that is actually Ko. So 9 plus 4 is 13. For the next triangle, the middle one, so take note that the right angle is located at N here, okay? And then this angle here corresponds to angle O. So this would be angle O, okay? So we have the same angle. Therefore, the remaining vertex is A here, right? And finally, for the smallest one, so it's still, the right angle is still at N. This angle corresponds to the largest triangle K. So this K, this should be K here, and the remaining is actually A. Okay, that's how you label it. Corresponding angles here. So, and then complete with the unknowns. So for smaller one, you have Kn is 4, AK or Ka is Y, and you have here X. And for the middle one, or the average size or the medium size, you have NA or AN is X, and then you have NO, which is 9, and AO, which is Z. Right? Next thing here is which to be paired. Now, if you're going to pair this two triangles, you will come up with the proportion of sides Kn over An, and we have Kn over An is equal to, let's have the hypotenuse, Ka over AO, and we have the leg here is equal to Na over No. And plot the values and see if you could have you could come up with a ratio or a portion that you could solve. Kn is 4, An is X, you have Ka is Y, AO is Z, and then you have Na, which is also X, and NOO, which is 9. And looking at this, we have multiple variables here. But then look at the first and the last. You could actually pair it and solve for X. Okay, so let me increase the size here, the bottom. Okay. We could pair it later on, but we could prepare it for other solutions. So you have 4 over X is equal to X over 9. You have 36 is equal to X squared. Square root of both sides. X is positive negative 6. But since these are all measurements, we'll only accept x is equal to positive 6. This is the value for x. Okay. Once we have this, when we substitute it here, 4 over 6 and 6 over 9, it will not still help us because y over z are both variables. But what could help us is place the values here. You have the value for 6, and here is the value for 6. At least we have solved already for the value for x. Again, we cannot use this relationship anymore because again, y and z are both variables. So what we can do next is to look for other relationships, specifically the medium and the bigger. Okay, so the medium for and the bigger, you will have an over ka is equal to ao, the hypotenuse here, over ko equal to no over ao. Substituting all values, an is x, which is actually earlier as 6, over ka, which is y, is equal to ao, which is z, over the value for um, ko, which is 13, equal to no, which is 9, over ao, which is z. As you can see, we can use this 2 ratio to solve for z. So we were just going to wait for y later. Okay, we are going to use that for z. So to do that, you have z squared is equal to 9 times 13. Let me just write it this way so it would be easier for us. Because when we take the root of both sides, we'll have positive, negative, square root of 9 times 13. I did not multiply it because you could actually remove 9. So z is equal to positive, negative 3 square root of 13. But since again it's measurement, we shall only accept z equal to positive 3 square root of 13. This is the value for z. Okay. Now we could substitute here z in this equation here if you want to. So we will have square root of 13. That's square root of 13, sorry. We could substitute here z to solve for y. And that would become 6 over y is equal to 3 square root of 13 over 13. So you will have 6 times 13, right? 6 times 13, which is equivalent to 78, is equal to 3 square root of 13 y. Divide both sides by 3 square root of 13, right? So you will have y is equal to 78 over 3 square root of 13. 78 can be divided by 3, right? Which is actually equal to 26 square root of, sorry, 26 over square root of 13. Rationalize this one by multiplying square root of 13, square root of 13. Let me increase more space here. Okay, so you have 26 square root of 13 over square root of 13 times square root of 13. You might want to review radicals for this. It's just 13 because that's square root of 13 squared. Divide this 2. So y is equal to 2 square root of 13. This is also the possible value for y. Okay. If you're not convinced with how we solve for y, we can do checking. At the same time, this is also the other process of solving value for y. What is that? Let me go back to the given. Since x is already is y sorry z rather, since z is already given to be 3 square root of 13, we can actually solve for y using the Pythagorean theorem. Take note that the hypotenuse here is 4 plus 9, which is 13. We all know that the Pythagorean theorem has the generic formula. The square of the hypotenuse is equal to the sum of the square of its legs. Hypotenuse is 13 squared. A, you may use this, y squared plus your b, which is 3 square root of 13 squared. And then that's 169 is equal to y squared plus, distribute that, 9 times 13. 169 is equal to y squared plus 9 times 13 is equal to 117. Subtract both sides, y squared is equal to 169 minus 17, 117 rather, is 52. Take the root of both sides, you have positive negative square root of 52. 52 is actually 4 times 13. So y could either be positive, negative, square root of 4, which is 2, then square root of 13, but only take the positive value. So you have 2 square root of 13. As you can see, this is also checking of the value earlier. It depends on you now which is easier for you. But aside of it being a checking, that is also another method. When you go back here to our three different triangles, you already have 4, you already have 6 here. You could always solve y using the Pythagorean theorem. Earlier, you have here 6 and you have your 9. You could also solve for z using the Pythagorean theorem. Right? You could also use those processes. After all, the goal here is just simply solving for x, y, and then z. So my hint and my advice again for everyone, for your right triangle similarity, you may always break the triangle and give the three different triangles, plot the given values, plot carefully rather, and then solve for the sides using the proportionality statements. Okay, so please continue in reviewing as you prepare for our exams. Thank you very much. Goodbye.